Hi, kids. Hey, I want to do one more proportional reasoning with you, and I'm gonna lose this stuff. But I want to do one more proportional reasoning with you. Um, Michael Jordan's vertical in his heyday was 4 feet. His hang time in his heyday was 1 second. So I want to tell you, if he wanted to double his hang time, how high would he have to jump? And then also, how many times faster would his initial jump speed have to be? So I want to show you guys a different way of approaching this. So I've kind of, in the other videos, we've already talked about, a couple different approaches. I want to show you guys how we could relate this to our linearization stuff that we've been doing. So if I want to draw a picture of what's happening here, it would be like, hey, I got Michael Jordan. Here he is, and he jumps up, and his vertical is 4 feet. Remember, his hang time would be vertical would be A to B, and then hang time would be A to C. But again, he's starting, ending at the same height. So there's my picture. If I wanted to say, all right, so I want to relate how high he jumps, which would be, if you're thinking about this, really there is no X, so it's just the Y side. Hopefully that makes sense. Just your vertical. If I was talking about his vertical jump, that would be Y, and I want to see how that relates to time. And really, it doesn't matter. I could go A to B or B to C. If I think about this equation that was on your formula sheet, just to make sure you guys understand, I would actually be going B to C because my initial velocity would be 0, so this whole thing goes away. So I end up with, hey, y is equal to 1/2 at squared. Or if we wanted to look at this with a graphical way, it would look like this. Okay, that hey, y, if I was to graph y and t, I would get that. Well, if I wanted to make it a line, I would have to graph y versus t squared, and I would get a line. And if we were actually doing numbers like we did, so let's say we were graphing, t and then y, and then if I wanted to linearize it, I would have to graph t squared. So like if we were thinking about it in this way, well, what is actually happening at the beginning? I'm doubling his hang time. So this is times 2. Well, remember, if I wanted to linearize it, I would have to do t squared. You'd have to make this other column. So this would be times 4. So that, hey, this is proportional to this. So that would also be times 4. So if he wanted to double his hang time, this would be insane. He would have to jump 16 feet in the air. Wow. So, but hopefully, just as far as another way you guys can think about proportional reasoning and have it make sense. If you wanted to figure out how many times faster would he jump, so this is talking about my initial. Okay, if we were to, again, in this case, I'd probably want to go A to B. So if I was to write it out, it would look something like this, where this would be 0, and you would end up with V0 equals, it'd really be this, AT, but this is negative, this is also negative, so that if I was to graph this one, it would be like, hey, I'm going to graph V0 versus T, it's going to be a line, and then if I was to, say, hey, I want to linearize it like we've been doing, T and V0, well then, hey, if you look, how many times faster we have to jump to double this? Well, if this is times 2, well, this is already a line, so that's going to be times 2. So then how many times faster? He'd have to jump twice as fast with twice as much initial velocity. So hope that helps. Bye, kids.